Hi, 8th graders. Today we are going to change repeating decimals to fractions, which is part 2 of lesson 1-1. So we already changed terminating decimals to fractions, and now it's repeating decimals to fractions. So these 6 steps, I just want you to, pause the video, write these 6 steps down. I know they're not going to make any sense at the moment, but if you could read these 6 steps as we work through the examples that I have, that would be great. So just take a little bit of time on these and write them down. You're going to have to either write these down on another piece of paper, or you're going to have to go to the back of your book where there's extra sheets and write them down there. So take that time, write these 6 steps down, and we will just start with the examples here. So hopefully you paused me, and we will start with the examples. So example 1, we're going to change 0.7 repeating to its fraction. Okay, so 0.7 repeating to a fraction. If you look at the steps, it says step number 1, identify the number of digits that repeat. There is one digit, 7 is repeating. So one digit. And number 2 says assign the correct power. So assign 10, 100,000 to match the digits. One digit means I need to use one digit. You're going to use 10. Okay, so 10 has 1 0. That's why it's one digit. So that's the first thing to figure out. So basically steps 1 and 2 are done right now. Step 3, set up the equation and multiply by the proper power of 10. This is the harder part. If you do not write these out, you will never get these. Okay, I cannot stress that enough. If you are not willing to write out the steps, you'll never get these. It's quite abstract, and you just kind of have to go with the flow and do what I say. So the first part, you've got a left side of the equation and you have a right side of the equation. Okay, the left side is you're going to write the number you used, which in this case is 10. And you're going to put an X there. Now, this whole time you need to remember that X is 0.77777, okay? So, to be equal to this left side of 10 times X, you actually need to take 10 times X, which means that 10X means that you're going to take 10 times that 0.7 repeating. Okay, so this is the key. Now, what happens when you take 10 times 0.7 repeating, you got to kind of remember that you're taking 10 times 0.7777. That never ends. And so when you take 10 times something, all it does is moves the decimal once to the right. And so 10 times 0.7777 really ends up being 7.7777. So all you did was shift that decimal 1 to the right, okay? And since you did that, that is what goes over on this side. So 10 times X, here was my X, 10 times that number is 7.777, okay? It's not like the 7s ever end. So we have the first equation set up. And that is the key to getting the whole problem right. All right, so number 4, subtract 1x on both sides. So 1x minus 1x here. But I also have to subtract 1x on the other side, but you have to go back. 1x is actually the decimal they gave you in the very beginning. So you're actually going to subtract 0.7 repeating from 7.7 repeating. And so when you subtract decimals, remember you have to line them up, line up the decimals, and then you have to just subtract straight down. Now, if I'm subtracting this part, 10x minus x, you're going to get 9x, okay? Drop your equal sign. Now, if you take 7.7 repeating and you subtract the 7 repeating, I mean, it's just some logic here. Remember, this is 0.7 repeating. We just don't write the 0. Now, when you subtract decimals, remember, you always start over here on the left side. Well, there's 7 over 7 all the time. So, like, what's the point of subtracting 7 over 7 all the time? Because you're just always going to get what? 0. So 7 minus 7 is 0. And then this last one is 7 minus 0, which is 7. So that right there is the hard part of it. The rest of it is really easy. We subtracted 1x on both sides. Divide by 9, 99, 99, or whatever you have. This one I'm going to divide by 9 because I need to get rid of that 9. You've seen this a million times before. So x equals 7/9. So I'm going to pull out my calculator here. And so 7/9, if it's going to work ever, 7 divided by 9, in this case, should be 0.7 repeating. Now, my calculator here is rounding that last digit. It is still repeating. So just realize that if your calculator does that, it's just rounding. So we know that 7.7 repeating is 7/9. Whoops, wrong thing. Okay, so 7/9 is the fraction. And what is equal to 0.7 repeating? So 7/9 is equal to 0.7 repeating. We know that. Okay, so it's quite the process, but like I said, I would say that steps 3 and 4 are the most important steps, and assigning the correct number. 5 and 6 kind of happen naturally and aren't as hard. Okay, we're going to do another example. We're going to change a repetant 16 to its fraction. All right, so step 1 said, determine how many digits are repeating. There are 2 digits this time. The 1 and the 6 are repeating. So that means that you're going to use 100 this time in your equation. So you set up your equation, 100x. It's always this way. Now, this is the important part. You actually need to take 100 times your x, but remember your x is 0.161616. So you're actually going to take 100 times this 0.16 repeating. Now what happens is that now you're taking it times 100. That actually just moves the decimal 2 times to the right. So 100 times 0.1616 ends up being 16 point, and it's not like that 161616 ever ends. It just keeps going and going and going. But on the very first line, that's what you're going to put is that 16.16. I don't like to use the bar in the equation. I like to write out a couple 16s or a couple of repeating decimals. So that's what 100 times your number was. It just moves the decimal twice is all it did. Okay, same thing, subtract 1x. But remember, your 1x is this number. It's basically you're going to put that 0.16, that x, you're going to put it right under there and line it up. That's the whole point, is to get rid of the 16 repeating part. Okay, so basically you took a number that you took times 100, that one you took times 100, and you're subtracting the original number from it. That's all you're doing. All right, so 100 minus x this time is 99x. And 16.16 repeating minus its 0.16 repeating, it gets rid of all of that repeating junk. That is the point. So that's going to equal 16. Then you're going to divide by 99. Okay? And so x should be 16/99. So if we check that, let's check 16/99 here. Or do some Wheel of Fortune. 16 divided by 99. Should be that repeating decimal that we had. Yeah, there it is, 0.16161616. Okay, so there's the repeating decimal that we've got. So we know that that is the right one. Okay, you can check that on a calculator. Next example, 3.040404. Now this time it's got a whole number involved. So what I say is don't worry about that whole number for now. Wait till the end to worry about it. Really, all you're going to worry about is 0.0404. If you worry about 0.04, it ends up being exactly like the 0.16 problem. Okay, there are now 2 digits repeating. So you're going to use 100. Okay, 2 digits means 100. You're going to actually take 100 times this 0.04. So 100 times that number moves that decimal 2 times to the right. Okay, and then I'm going to erase that real quick. That's going to make it 4 point. Now remember, 2 times to the right, but then the next number in sequence would be a 040404. It's not like they're going to stop. Okay, so then you're going to subtract x. That is basically taking your number and putting it under here. Decimal under decimal, 0404. Okay, that wipes out the repeating stuff. 100 minus x is 99x, and 4, it's going to equal 4, divide it by 99. So x equals 4/99. You can check it. 4 divided by 99 is the 0.040404 part. Now remember, when you're doing this, you've got the 3 from the beginning. So final answer here is 3 4/99. Okay, those are about as difficult as they go for the most part. We're going to do some more just because I think they're good to see. 0.00, and let's say just the 4 repeats here. Okay, all right, so 0.004. There is still 1 digit repeating, so you're only going to use 10. Okay, only the 4 is repeating. Now, if you take 10 times that number, that's going to slide that decimal to the right, and it's going to put it between the zeros. So 10 times that number is actually 0.044444. It's not like the 4 stop, okay, but it did chop off one of those zeros from the original by moving it once. Still going to subtract 1x. That is always going to stay consistent. Now, the tricky part is now taking this 0.004 and putting it under here. That's the tricky part. It doesn't have to be tricky, but it kind of is. So, the decimal goes here. The next number was a 0. The next number was a 0, even though they don't match that 4, but we're still going to get a lot of the repeating stuff. All these 4 repeatings, those are going to go away. So notice everything's lined up. This top number was taken times 10. This bottom number was not. It's the original number. All right, so when you subtract, you 10x minus 9, that makes 9x. Okay, now this is where you got to be careful. So all these 4s on this side would go away. 4 minus 4, but then we've got this part to solve. 4 minus 0 is 4. 0 minus 0 is 0. And then drop the decimal. Okay, not too terrible. Basically, you took 0.04 minus 0.00. Divide by 9. Okay, now this one needs to be adjusted. Okay, so you have to adjust it. You can't have a decimal inside of a fraction. The adjustment is super easy. So if you had 0.04 over 9, all you have to do is take both the numerator and the denominator times 100, because you need to slide that decimal to the right twice. So if I'm going to adjust this, 0.04 times 100 is 4, but 9 times 100 is 900. Okay, and then after that, you would want to go a little bit farther. You would want to simplify 4 over 900. Let's check 4 over 900 before we do that. So 4 divided by 900. 0.004444. Okay, so there's that. Then you would want to scroll down there. Divide these both by, well, I guess we could start with 2, but I'm thinking 4 is going to go in there. So by 2 is going to be 2 450ths. Okay, you could do it again. Should have done it by 4. It's okay. So that's going to be 1, and then that's going to be 225. So if I checked 1, we're going to try to pull this up this time. 1 over 225. 1 divided by 225. We should get that 0.00, there it is, 0.00444444. So that one was a little bit different and, you know, just a little bit harder because of the lineup issue, but the rest of it is the same. Once you get the knack of it, it's not that bad. Okay, we'll put that away for now, and then we'll go to the next one that I have. 2.1 with a 5 repeating. Okay, you don't need to worry about the 2. We're just going to worry about the 0.1 with a 5. Okay, so this part is still 10. I have one digit that repeats, and it's the 5. And now if I actually take that times 10, I'm going to move it once. So if I take this number times 10, it actually turns into 1 point, and then the 5s don't ever stop. Okay? You subtract the x. The x is actually 0.15 repeating. So this decimal has to go under the other decimal. The 1 is the next number. The 5 repeating, we will get rid of some of those 5s. Actually, we'll get rid of the 5s from here to here. Everything in there is going to go. All right, so 10x minus 1x is 9x. And now you're just basically taking 1.5 minus 0.1. 5 minus 1 is 4. You drop the decimal, and you got a 1. There wasn't even any borrowing that you had to do there. Okay, and then you divide by 9. And then this one needs an adjustment. You can't have 1.4 over 9. This one's adjustment is not as bad as the other one. So this one's adjustment, you need to take it times 10 to move that decimal once. You need to make the numerator a whole number. So taking it times 10 makes it 14 over 90. And then you could divide by 2 to simplify it. As long as you do the same thing to the top and bottom of a fraction, you're going to be good. So 14 divided by 2 is 7, and 90 divided by 2 is 45. And then from the very, very beginning, you had a 2. So 2 and 7/45. Let's check what 7/45 is. Hopefully, maybe if I can. There we go. So 7 divided by 45. Is that my, yes, 0.15555, and if I wanted to put the 2 on there, I could just put plus 2. There is my decimal. Okay, so 2 and 7/45 is what that decimal is. Okay, another one. They're all just a little different, but the sequence of what you're supposed to do is the same thing. 0.01 and just the 6 repeats. All right, so I'm going to use 10. Okay, so this number times 10 is going to move that decimal once to the right. So this number times 10 is 0.1666. Okay, and you're going to subtract x, but that's this original number. So it's going to go, there's the decimal line up, the 0, the 1, and then there's the 6 finally. It's going to get rid of those 6s. So we get rid of 6s from here to here. All of those make 0 when you subtract. 10 minus 1 is 9x. That's pretty easy. And then now you're just doing this 0.16 minus 0.01. 6 minus 1 is 5, and 1 minus 0 is 1, but we have that decimal. It's just going to need an adjustment at the end. Divide by 9. X equals 0.15 over 9, but we can't leave it like that. We need to take that times 100 because I want to move that top number twice. So if I take that times 100, I'm going to get 15 over 900. Well, 15 over 900, at least a 5 would maybe go in there. Okay, so 15 divided by 5 is 3, and 900 divided by 5 is, let's see, 90, 180. I can actually go again. I should have done it by 15, but I didn't know that at the time. So divide that by 3 again. You're going to get 1, and then 3 goes into 18, 1/60th. So let's see what 1/60th is. If I can. Here we go. Okay, 1 divided by 60. And there it is, 0.01 with a repetent 6. And that was our original decimal. So we're definitely good with 1/60th. Okay, one more. All right, we got negative 4.00 with a 2, 6 repeating. The 2 and the 6 are repeating this time. This will be the last one. Once you get this down, all of them are pretty much the same. So the -4 part I'm not going to worry about. I'm just going to do the 0.0026 part. All right, this time it's 2 digits, so I'm going to use 100. And if I actually take this number times 100, 0.0026, repeating, if I take that number times 100, that moves this decimal 2 times. So this number times 100 is actually 0.262626, because that's the part that's repeating, and I'm resetting the decimal by that 2. Subtract x, but that's this, and so now you got to line things up. So here's the decimal, the next number is a 0, 0, and then there's the 2 6s. Eventually it will line up and it will cancel things. All of that's gone. It canceled. And this one actually doesn't turn out to be that terrible. 100x minus x is 99x equals 0.26 minus point nothing is 0.26. So we divide by 99. And we need to adjust this. So I'm going to multiply by 100 again. Why 100? Because I need to move that twice to get it out of the 0.26. So now that makes 26, and then you're just going to add 2 zeros to this 9900. All right, so you can at least divide that by 2 to simplify it, because they're both even numbers. So 13, 26 divided by 2 is 13. 9,900 divided by 2 is 4,950. Now the only way that you would be able to simplify this is if 13 actually went into 4,950. So I will check that real quick for you guys. 4950. I doubt it. No. Nope. So it's simplified. You only need to simplify it down. Let's check what 13 divided by 4,950 is. And it is 0.026262626. So we know that we are good on that answer. Okay, so if you kind of look at everything, it's all about setting up this equation. Most of yours today won't be any more difficult than, you know, this one, the first 3, basically. But I did want us to practice some of the more difficult ones just to get the process down. You might see this on a map test. Your points would go up if you actually got that right on your map test. So we'll work through this, asking questions, especially about this lining things up. That's probably the hardest part, but hopefully you've seen enough of them that you can kind of pick up on them. Okay.